divided by x square minus 1 is equal to 2. You square both sides, you get 2x square plus 1 divided by x square minus 1 is equal to 4. Squaring both sides in order to remove the radical. Now you cross multiply. Right?
Yes, sir.
Case 2. The second value is y equal to 3.
3. Yes, sir.
Again, squaring both sides.
Yes, sir.
Cross multiply. Right? So what are the roots? In the first case 1, I had got plus or minus root 6. Okay. And the second one,
Yes, sir.
plus or minus root 5. We're actually getting 4 roots in this. Okay. And why are we getting 4 roots? Because the degree of this equation here is 4. Okay.
Okay.
Because if you see the
Sir, but
equation
the
here,
answers are not matching.
answer is not matching. What is the
Yes,
answer?
sir. The answer is plus minus root over 5 by 2 and plus minus root over 10 by 7.
Root over 10 by 7 plus minus root 10 by 7.
Yes,
And
sir.
have I solved this correctly?
Sir, can you say the answer? The right answer.
Just wait. This is y minus 2 into y minus 3. Yes, this is okay. So I think there's something, either the question and some signs are different, due to which you are getting the different answer. Understood? Maybe
Yes.
you have x square plus 1 or something somewhere. That is why. But then this is the way you work with it. Okay.
Okay, sir.
So you can take this question. There's no harm in this question. Okay. Yes. Who was saying what?
Sir, I think I got the answer.
Arpita. Yes. Tell me.
Sir, I think that I got the answer.
Tell me. Tell me how.
Sir, it x equals.
So that if you see, I think in that sum, all the signs were plus signs, right? So I think this is the actual sum. Okay. So what
Yes,
you do
sir.
is you categorize this. That is, you write this as x into x minus 1 together, because if you multiply, you'll get x square minus x. And you take these two together, x plus 2 and x minus 3, you take together. Because if you multiply these two, you will get x square minus x also and plus something. Okay. So in both the cases, here as well as here, you're multiplying, you are getting x square minus x here. And here you're getting x square minus x plus something. Okay. So that is why you group these two together. Now we'll see after multiplication what we get. After, if you multiply these two,
Sir, I have sent you the picture.
okay, I'll just check. X square minus x, this is, and here you will get x square minus x minus 6, and you have a plus 8 here. Okay. So what you do here is you assume let x square minus x is equal to y. So therefore, you get y into y minus 6 plus 8 is equal to 0. So that now if you multiply and express it in quadratic form, you get y square minus 6y plus 8 is equal to 0. So that now you can factorize this into y minus 2 into y minus 4 equal to 0. That means you have either y is equal to 2 or you have y equal to 4. We have two values of y. We work with both the values. Case 1, when y equal to 2, you have x into x minus 1, or let's say x square minus x. We had assumed x square minus x equal to y. So x square minus x is equal to 2. That means now this is a quadratic that you are getting, x square minus x minus 2 equal to 0. So you get x square minus 2x plus x minus 2 equal to 0. So that now you get x minus 2 into x plus 1 is equal to 0. So you're getting x is equal to either 2 or minus 1, right, for this. And for the second case, this was case 1. For the second case, when y is equal to 4, so you have x square minus x is equal to 4. So that now this becomes x square um, minus x minus 4 equal to 0. Now this cannot be factorized, so you use your Shidaracharya. Therefore, x will be minus of minus 1 plus or minus root over minus 1 square minus 4 into 1 into minus 4 divided by 2 into 1. So you simplify this, you'll get 1 plus or minus root 17 divided by 2. So what are the roots? The roots of the given equation are 2 minus 1 and 1 plus or minus root 17 by 2. So what you see here is there's something that you must note in this. We'll come to all this in the next part. You must note here that 2 and minus 1 are called rational roots, obviously real. Okay. So there are 4 roots of this equation, out of which 2 are rational, and 1 plus or minus root 17 by 2 are called irrational roots. Okay. That is something that you must know. An equation can have a combination of rational and irrational roots. Okay. Also, what you must see here, that these two roots that you are getting here, this 1 plus or minus root 17, 1 plus root 17 by 2 and 1 minus root 17 by 2 are conjugate of each other. Remember in class 9 I had mentioned conjugacy, conjugate surds. Okay. So roots will always occur in conjugate pairs. Okay. Roots, or remember this, roots always occur in conjugate pairs. irrational roots in fact. Irrational roots always occur in conjugate pairs. Okay, so if I give you um, um, one root as, if one root of an equation is given to us as, say, 1 plus root 3, then the other root, you must know, then the other root must always be 1 minus root 3, because 1 minus root 3 is the conjugate of 1 plus root 3. How do we get the conjugate? If you remember again class 9, I told you just change the sign of the irrational part. So from plus, which is the sign of the irrational part here is plus, I change the sign from plus to minus. So I got the conjugate. So in order to get the conjugate, just change the sign of the irrational part. Okay, fine. So any questions here?
No, sir.
And from this one more problem I would have liked to work out, but because I want you to get ready for tomorrow's video, there are certain rules that I would like to mention just in case, because in that video in the beginning I found that maybe I have not mentioned the rules properly. Okay, so just take down the rules for the next part. These are the rules. Now, before I start, let me just take 2 minutes. Nature of roots of a quadratic equation. This is the next subheading that you are going to give tomorrow. Okay, now nature of roots, though I have discussed, there are some additional nature of roots here. Okay, so rule number 1 here is D is, is called the discriminant. D is called the discriminant of the quadratic. You know this already from your class 10.
Yes, sir.
So we'll check the root nature of the quadratic equation with the help of this discriminant. Okay, rule number 1. The first rule is that if D is greater than or equal to 0, then we can say that the roots of the equation are real. Okay, this we had discussed in last year in class 10 also. Rule number 2 is that if D is greater than 0 simply, then we say that the roots are real and unequal, or sometimes we use the word distinct also. Either I use the word real or you can use the word distinct. Okay, this is the second rule. The third rule here is that if D is equal to 0, okay, now then the roots are real, rational, and equal. Rational roots, I just mentioned rational roots. This is the additional word that you're going to note in your class 10. If D is equal to 0, I had told you that roots are simply real and equal. So this is another additional word that I add here, real, rational, and equal. Rule number 4. If D is greater than 0 and D is a perfect square, then the roots are real, rational, and unequal. Okay. Rule number 5. If D is greater than 0 and D is not a perfect square, then the roots are real, irrational, and unequal. Okay. And finally, rule number 6 is when the discriminant is negative. If D is less than 0, then we say the roots are complex. Now, what are complex roots? We'll discuss this. I've discussed this in the video yesterday also, right? So I'll discuss complex numbers in detail later on. But for the time being, just know the whatever I've mentioned in the video and what you mean by complex roots. Okay, so this is what these are what the rules are. Okay, now these will help you solve some of the problems yesterday. Note down these rules. Okay, now once you finish these the sums on these, once you finish writing these, you can also note down these. That is sum and product of the roots. So if I say let alpha and beta be the roots of this equation ax square plus bx plus c is equal to 0, then without even solving, you can say that the sum of the roots which is alpha plus beta must always be equal to the negative of this coefficient. You change the sign of this coefficient b and divide it by a. That is, you divide it by the coefficient of x square. Okay, so you can write this as minus coefficient of x divided by coefficient of x square. Okay, product of the roots. Product of the roots is alpha into beta will be c by a, which is the, let's say, constant term divided by coefficient of x square. Okay, so this is a simple example. If I consider alpha beta to be the roots of two x square minus x plus 1 equal to 0, then what can I say about the sum? Alpha plus beta is equal to minus b by a. What is b here? Let me write the coefficient for your convenience, but you will not, you will do this directly instead of writing the coefficients. So here a is equal to 2, b is equal to minus 1, and you have c is equal to 1. Therefore, what should be the product? Sum of the roots. Alpha plus beta must be equal to minus b by a. which you can write directly as minus of minus 1 divided by 2, which is half. And what is the product of the roots? C by A. C here is 1 and A here is 2. Okay, so sum of the roots is also half, product of the roots is also half in this case. And similarly, you can write it for any other equation that is given without even solving the equation. You can write down the sum of the roots and the product of the roots. Okay, so that is something that you need to know. Formation of roots, formation of quadratic equations, formation of quadratic equations with given roots. Okay, all this I have discussed in tomorrow's video, which I'm going to send you. Okay, I just want to take note of this together so that later on you don't have problem with the concepts. And then when I take live classes, I will be discussing this. So formation of quadratic equation. Suppose I have um, two roots are given to you of the quadratic equation. How will I determine the equation? Just the reverse, right? Till now, what have we done? We have given the quadratic equation and we are solving for the roots. But this is just the converse of this. That is, the roots are given. You need to form the quadratic equation. Okay. So in this case, here, if the roots are given, for given roots, for given roots of an equation, the resulting quadratic equation is x square minus sum of the roots into x plus product of the roots equal to 0. This will be a quadratic. So suppose if I give you uh, alpha and beta to be the roots, of a quadratic equation. Okay, so therefore, the resulting quadratic equation will be x square minus sum of the roots, which is alpha plus beta, x plus product of the roots, which is alpha beta. Okay, let us take a small example. Very simple one. I have given a better example in the video. Okay, it's here form a quadratic equation whose roots are half and minus 1/4. Okay, so roots are given. So the resulting, you can directly write the resulting quadratic equation whose roots are half and minus 1/4 is given by x square minus sum of the roots. What is the sum of these two roots? What is the sum? Half plus minus 1/4. This is the sum of the roots into x plus, and what is the product of the roots? Half into minus 1/4 equal to 0. Now you can simplify this a little and express it in x square plus bx plus c form. Half minus 1/4 x, and you have minus 1/8. half minus 1/4. If you take the LCM, you'll get 1/4 only. And now you can take the LCM. It is the LCM. You get 4x square minus 2x minus 1 into 0. That means you have 4x square minus 2x minus 1 equal to 0. And that is your quadratic. So you knew the roots, you were given the roots, you have formed the quadratic equation. Till now, you were getting the quadratic equation and you were solving for the roots. This is just the converse. Okay. So I'll stop here for today.